Hello students, in this video lecture, I will cover up deadlock introduction, what is the deadlock, how it occurs, what are the necessary conditions for deadlock, and so on. So overall, this video lecture will be treated as the introduction only. So firstly, we should know why deadlock occurs. If there are independent process, then there may not be any deadlock. But when there are cooperating process, then there is a chance of the deadlock. So firstly, we should know about the resources. Resources basically are the unit such as buses, printer, memory, CPU, etc. So some of these resources are printable and some are not printable. Printable resource such as that can snatched voluntary or we can say forcefully that can be snatched forcefully, for example CPU. If a process is allocated to the processor and that has not completed till yet but its time slot completed, that is a time quantum, or we can say a higher order process comes, so automatically the processor will be snatched from that process, so that are known as the printable. Some resources are non-printable, for example printer. If a printer is printing something and suppose that the printing has the 100 pages, a hierarchy process, a higher a higher priority process arrives and it has to print only 10 pages, so the printer will not get printed from the process previously that is allocated to it. So if a resource is allocated to a particular process, it will not get primed until it will not complete the entire execution. So printable and non-printable, there are two type of resources. Now coming on the deadlock. What is deadlock? So this is the one of the best example of real life. This is a river and there are finite number of stepping stones. If a person want to cross the river, so it has to put its leg on these stepping stones and then after it can cross the river. There are a restriction also. These stepping stones are non-shareable. Means only one step can be decided on this. This is not possible. Two person are standing on these two this stepping stone. So our step all stepping stones are the basically non-shareable mode. No one can preempt. Means if a person is standing here and if a person is standing here, suppose that there are two persons, it want to cross the river and it also want to cross the river, and both are standing at this situation or position. This want to go this side and this want to go this side. So this is the person P1 and this is the person P2. So this stepping stone S1 and S2, there are two stepping stone I have considering. This is not possible. P1 and P2, both person are standing on the single stone, that is S1 or S2. This is not possible. uh, the P1 can push back to the P2 now and print the stepping stone, or vice versa. P2 push the P1 and get the stepping stone. So such type of situation occurs as the deadlock. So when we are going to discuss about the deadlock system model, we must represent the resources. Resources are represented by R1, R2 up to Rm, and it is the memory, printer, etc. And each resource has some instances. Instances means, for example, suppose that a printer, printer is a resource, and the printer has four instances. Means a from a computer, four 1020 HP printer are connected. HP 1020. So there the printer has four resources. So four instances of printer resources. So instances means how many basically printer or the device that are allocated. So resource, printer, memory, etc. are treated as a resource, and how many in quantity. Those are known as the instances. When a process need a resource, firstly it will request for that resource to the system, then after use it, and after using it must release it. So request, the process request to a resource, I I needed this resource. If the request cannot be granted immediately, for example, the resource is being used by some other process, then the requesting process must wait until it can acquire the resource. For example, printer is busy to print something, so the process that is requesting must wait. Once it is allocated to it, the process can operate the resource. That is, for example, if the resource is printer, then process can print the printer, and then after it will release, or we can say return back the resource to the system so that another one can use. For example, in the olden days, we have the landline phones. If there is a mobile call, I am dialing to someone. So I will pick up the receiver, and then after I will call. And after calling, until I will not put the receiver on the phone proper in the proper manner, so no one can call me back. So we must release in the proper manner the resource to the system so that another one can use that. Now, characteristics or the necessary of condition of the deadlock. First one is the mutual exclusion. At, at least one resource must be in the non-shareable mode. Means the system should have at least one of the resources that cannot be shared among the number of by the number of processes. For example, printer is a non-shareable resource, while a word file is a shareable resource. A number of user can request or send their request as a process to read that particular file. So there should be at least one of the resource in the non-shareable mode. Second one, hold and wait. A process must be holding at least one of the resource and waiting for acquiring the additional resource that is occupied by some another process. So deadlock, for the occurrence of the deadlock, there is a second condition, hold and wait. Suppose that I am holding some of the resource and I am waiting for the another process. It uh, process, it may release the resource so that I can get those resources and execute and complete my execution. So I am holding some of the resources and another process is holding some of the resources. Both processes are holding some of the resources and they are waiting to one another. This may release the resource or it may release the resource so that I will get it. So neither will get completed its execution. No preemption. Any of the process cannot preempt the resource from other process until it will not voluntarily release it. Then after circular wait, if process P1 is waiting for the process P2 to release, P2 is waiting for the P3 to release, P3 is waiting for the P1 to release. So such type of weight is known as the circular weight. So for the deadlock, these four conditions must occur simultaneously. Then resource allocation graph. In the resource allocation graph, we can find whether there is a deadlock or not. This is the basic representation in which is a directed graph in which we will see there are two things. First one is the vertices and second one is known as the edges. The processes in the system are represented by P1, P2, P3 up to Pn, and resources are represented by the R1, R2 up to Rn. If a process is requesting for a resource, so there is a directed as such that PI, process I, is requesting for resource J. While in case of assignment is, if a resource is allocated to a particular process, so it will be depicted as Rj to Pi. That means this resource is allocated to that particular process. For more elaboration, we can discuss process is represented by the circular and resource by the rectangular. If a resource has four instances, so these are the four instances requesting is. So Pi is requesting for the resource Rj. Resource Rj has the four instance. Any of the resource it may get. So this is the requesting is. So it is not requesting for a particular instance. It is requesting for the resource. There are four instances of the resource. Any of the resource it may get. So it should be outside the circular, outside the rectangular. While assignment is means a particular instance is assigned to the particular process. So there will be an arrow from that instance to the that particular process. So this is known as the assignment is. Here, this is the broad example of the resource allocation graph. Process P1 is requesting for the resource R1. R1 is allocated to the P2. R2 has two instances. One instance is allocated to process P1 and another to P2. And P2 is requesting for resource R3 and R3 is allocated to the P3. So this is the generalized representation of the resource allocation graph. Although resource R4 have three instances, but no process is requesting for it. Now, ne- next topic, resource allocation. We have to check whether there is a deadlock or not. If there occurs a cycle in the system that have a single resource of a single instance of each resource type, then there must be deadlock. Otherwise, we have to check whether there is deadlock or not. For example, R2 is requesting for R2 is assigned to P1 and P1 is requesting for R1 resource R1 and R1 is requesting for P2 and P2 process P2 is requesting for resource R3. Sorry, R1 resource is assigned to the process P2 and R2 resource instance is also allocated to the P2. So here the, there is a cycle. Also here is a cycle. So if cycle exists and for example I am removing this one, this instance, if there is only single instance, if there is a single instance and there is a cycle, then definitely there will be deadlock. Otherwise it may or may not be. Here is also a cycle. If we will check it, so this may be a deadlock or may not be. We have to find it out. Otherwise, if it has a single instance system, then there must be a deadlock. For example, this is the resource R1, process P1, and this is the resource R1. This is the process P2, and this is the resource R2. P1 is requesting for resource R1, and R1 is allocated to the process P2. P2 is requesting for resource R2, and R2 resource is allocated to P1. So here is a cycle, definitely there will be a deadlock. If graph contains no cycle, then there will be no deadlock. If graph contains cycle and only one instance of each resource type, then there will be a deadlock. Otherwise, there is a possibility of the deadlock. This is all about the basic concept of the deadlock from my side. Thank you.